In this video, I'm going to demonstrate looking at a hypothesis test of two population variances. What I've done is I've written up here our data from white paper 12.1, problem number 1. Basically, this question says we have two different routes that we can drive to on a regular basis, in this case to drop off and pick up somebody, a girl from hockey practice. What we did is we went in and we sampled 9 times taking the back roads, and we found a sample mean of 20 and a sample standard deviation of 4.5 minutes. Then we went and sampled 10 drives on the expressway, and the sample mean was 20.5 and the sample standard deviation is 3.5. So if we look at an example like this, so we've already hypothesis tested population means. That's certainly a critical thing to understand what our average time is in this case. But one thing that we also need to really focus in on then is the variation. And so what we can do in this case is we ask the question in the problem, is there a difference in the variation in the two drive times? Literally, we're trying to figure out, is there a difference in the variation of the drive times? And in this case, at a significance level, at a significance level of 0.10. Okay, so our first step, we're going to follow our standard kind of 5-step process that we've been doing for all of our hypothesis testing. H sub 0, H sub A. So our null hypothesis, basically, so for the first time now, we're looking to hypothesis test 2 different population variances. Okay, now in this case, the question simply asked, is there a difference between those 2 different routes? So it's a equals and a not equals, it's a 2-tailed test. In this case, I'm going to put the back roads first in my statements and the expressway second. Now, I'm doing this partly because my sample information indicates that my sample standard deviation is higher. And if you remember, when we looked at F distributions, right, somewhere in this F distribution, we're looking at this ratio and we're looking in this case of the ratio of the 2 different sample variances, and somewhere in here we go above 1 and somewhere in here we go below 1. And we want to ensure in this case that we're working on the right hand tail. The reason is, in this case of course we have a 2-tailed test, but if you look at differences, if you will, and kind of our vertical, all right, distance versus our horizontal distance, okay, the geometry of this particular probability distribution is going to require us to be much more accurate on the left-hand tail than the right-hand tail. Again, if we look at differences in kind of this distance in the vertical versus this distance in the horizontal, it's quite different from the right to the left. I can remember, a textbook that we used a long time ago for BA 254 kind of acted like this left-hand tail never existed. That's not true. There's some really clear reasons why we would prefer to work on the right-hand tail. And again, in this case, because it's an equals and a not equals, it's not quite as important. But when we start to introduce inequalities into our null and alternative hypothesis, we want to try to ensure that we're working on the right-hand tail. Okay, so our statements are similar but slightly different in that we're now looking at 2 variances. Our second step here is to state our significance level. Again, our type 1 error we're saying is 10%. Step number 3, when we start to actually go in and calculate these different F calculated values, all right, I was about to say the fun part. The better part is this is a much simpler calculation than what we've seen before or prior, especially when we were looking at our 2 sample tests of mean and proportion. We're basically, again, going to look at this ratio between the variances. Now, I put the back roads in the numerator and the expressway in the denominator. Why? Because I'm also making sure that we're putting that first here. Again, this is going to help further this idea that we want to work on the right-hand tail. In our case, when we go in and we calculate then our calculated value, our back road standard deviation was 4.5 squared to get our variance, 3.5 for the expressway. If we calculate that value, we end up somewhere right around 1.653, okay? Now, as we look ahead to putting together a decision rule, right, Now our decision rule is exactly the same as we've been dealing with. We're going to start off by saying reject h sub 0 if, right? That's been very consistent. Even when we're using p-values, we're very consistent that our decision rule is starting off the same way. But now we're going to say if our f calculation, all right, is greater than some critical value. So if f is then greater than some critical value, then we're going to reject h sub 0. Now to do this, what we've got to go in, we've got to go into a new chart. We're going to go into our f distribution table. And we're going to, again, look at the degrees of freedom in the numerator and the degrees of freedom in the denominator. In the numerator now, we've got the back roads, all right? And in the numerator, we have the back roads. In the denominator, we have the expressway. So now we had our back roads was 9 minus 1 divided by 10 minus 1 gets us to 8 and 9 respectively. If you go back in and then you look at the F distribution table, you're basically, of course, we're going to concentrate on using the F distribution table that is for, in this case now, this table down, or this area down here is 0.05. We've got 5% there, and we've got 5% there. So we want to focus really clearly on that particular table. When we go in and we look at that table, you're literally just kind of playing Battleship, and you're finding out where those two degrees of freedom meet up. And when that meets up, we find an F critical value now, an F critical value equal to 3.23. So we're going to reject h sub 0 if our F value is, in this case, greater than, of course, positive 3.23. Step number 5, right? We're simply answering that question. We're saying, where is this calculated value in relationship to this critical value? Well, here it is, 1.653. It is not in this rejection zone, so we would say, do not reject h sub 0. We've now made our decision. We're saying that, yeah, it appears as though from our sample information that there is a difference in the variances, but when we run that through our hypothesis testing model, we can't say with statistical support that couldn't be due to just kind of the general probability driving those numbers. In the next video, I will make a quick one, a little less busy, but a quick one where I'll try to talk about and address how we might, if we wanted to, solve this hypothesis test using a left-hand tail. So basically the same information, only it'll be in summary, and we'll address this. But again, the preferred method in solving these F distributions is to use this right-hand tail, and because, again, that allows us to be, we don't have to be nearly as critical with our accuracy as we would if we solved it on the left.